Okay, now here's what we have so far. Okay, we have quadrilaterals, and we have our parallelograms, and then under parallelograms we have the rectangle and rhombi, and then the rectangle and the rhombi come together to make the squares. Okay, that's what we've done so far. Yours is probably laid out a little bit differently. I'm just trying to fit it all in this one PowerPoint slide here. Now, my PowerPoint here, this is an old PowerPoint that I've used before. It says here to be discussed on a later date. Well, guess what? Right now is the later date. We're going to do it all at one time. Okay. What we have over here on this side is we have the side of the family that has two pairs of parallel sides. Parallelograms have two pairs of parallel sides. So do all the kids under parallelograms. Okay. Notice Grandpa Quadrilateral doesn't have any parallel sides. He's just the descendant. All the angles add up to be 360. So here it's all based on parallel sides. Two pairs of parallel side, and the other side is going to be the trapezoids. Okay, so under quadrilaterals on the right side will be the trapezoid family. Okay, and trapezoids are different from parallelograms because they only have one pair of parallel sides. Okay, the definition of a trapezoid again is a quadrilateral with only one pair of parallel sides. Here we have AB is parallel with CD. We see that AC is not parallel with BD because if AC were to keep going, it would actually cross BD. Okay. Now, let's just name some parts of trapezoids. The base angles are the angles that make up the parallel sides. So angle A and angle B are base angles, and angle C and angle D, which go together, are also base angles. So make sure you label those on your family tree. We call the legs are the non-parallel sides. Okay, this is different from the legs of a right triangle. These are talking about the legs of a trapezoid. The legs are the non-parallel sides. Okay, so one special case or one special condition for trapezoids is a segment called the median, and the median cuts the legs in half. The median is the segment that joins the midpoints of the trapezoid legs. So if we go from midpoint of this leg to midpoint of this leg, then the median cuts those in half. Okay, the length of the median is equal to 1/2 of the two bases added together. Okay, the bases are the parallel sides. So whatever this side is and whatever this side is, if you were to add those up and divide by 2, you would get the length of the median. Okay, not quite sure how much in depth we're going to go into problems with trapezoids in this class in Math 1. This is a little bit more into the geometry side of things. But I do want you to understand that trapezoids have one pair of parallel sides. Okay. Now under trapezoids, trapezoid is a lone father.
This game is awesome. Yeah, way cool.
Yeah, way cool. All right. So under trapezoids, there is one descendant, a special kind of trapezoid called an isosceles trapezoid. Okay. Remember, trapezoids have one pair of parallel sides. Okay. The parallel sides are on the top and the bottom here. Okay. But what's special is that the legs are congruent. Okay, there's your parallel sides. The legs are congruent in this case. Isosceles means having two sides congruent. Just like in a triangle, two sides are congruent. In a quadrilateral or trapezoid specifically, if two sides are congruent, that would be an isosceles trapezoid. All right. Definition again is a trapezoid where the legs are congruent. And what's special about these, and I'm pretty sure you will see these type problems on the EOCT, is that the base angles are congruent here. So what we're going to do is, remember the base angles are the angles that are associated with a parallel side. So here, the 2 dots and 2 dots, those two angles are actually going to be congruent, just like these two angles are going to be congruent. All right? As you can tell, I had fun with sounds on this PowerPoint. Here's the overall quadrilateral family tree. Just a snapshot without any of the rules or special cases. We have quadrilateral, who is the grandfather at the top, had 2 sons. One son is parallelogram, and the parallelogram family is broken up into rectangles and rhombi, and the rectangle and the rhombi came together and had the little baby square. Okay. On the right side of the family tree, we have the trapezoid, and the trapezoid is a single father who had the isosceles trapezoid. Okay, so know the difference. Quadrilaterals, 4 sides. Parallelograms, 4 sides with 2 pairs of parallel angles. Trapezoids, 4 sides, 1 pair of parallel sides. Okay. Rectangles. Rectangles are parallelograms, also quadrilaterals, but they have 4 right angles. Rhombus. A rhombus is a parallelogram and a quadrilateral, but a rhombus has 4 congruent sides. Square. A square is a rhombus, a rectangle, a parallelogram, and a quadrilateral. Okay, so squares are very, very special. Okay. Trapezoids, again, 1 pair of parallel sides. They're also quadrilaterals. And then underneath them is isosceles trapezoids with 2 pairs, 2 sides congruent. They are, they have 2 sides congruent. They have 1 pair of parallel sides, and that makes them a trapezoid, which also makes them a quadrilateral. Everything on the screen, the angles add up to be 360. Remember that, okay? Also remember the special cases and the rules for everything else below.
Elvis has left the building.
Not yet, Elvis. This is a way to kind of show you in a Venn diagram of how the quadrilateral family tree is broken down. And you could put this on the back of your family tree if you have room, or put it on a new page. But if the whole page represents the group of quadrilaterals, then we have specific groups that would be like the parallelogram group would be in this bubble. And inside of the parallelogram group would be the rectangle group. And then also inside the parallelogram group would be the rhombus group. And then where they overlap, and you see I couldn't draw very well with my mouse, of course where red and purple overlap, blue overlap is kind of purplish, and that would be your squares. So if I were to put my mouse cursor here, I'm touching the rectangle group, but I'm also touching the parallelogram group, and I'm also touching the quadrilateral group. Okay, so that tells you that rectangles are rectangles and parallelograms and quadrilaterals. Okay, if I were to put my mouse, say here on squares, it's touching squares, rectangles, rhombi, parallelograms, quadrilaterals. Okay, so it's touching everywhere. If I were to put my mouse here in the yellow, I'm just touching a quadrilateral that's not a parallelogram. Okay, don't forget the other side of the family is trapezoids. Trapezoids are not going to overlap with parallelograms because it's all based on how many pairs of parallel sides you have. Parallelograms have 2 pairs of parallel sides. Trapezoids only have 1. And inside of trapezoids, we have isosceles trapezoids. So again, if I were to put my mouse here, I'm touching an isosceles trapezoid, I'm touching a trapezoid, I'm touching a quadrilateral. So there you go. Hopefully that breaks it down for you. All right? All right, can't wait to see your family trees tomorrow. See you guys.